We need to use Venn diagrams to prove De Morgan's laws. To prove De Morgan's laws, let's first talk about what they actually are. So what is De Morgan's law? Well, the first one that we're going to look at is where we have A union with B. And then we are going to have the C right here. And we'll go over what this C means in a second. We also are going to have A intersecting with B. And then on the outside of this, we're going to have raised to the power, or raised to C. And we'll go over what this is as well. We're going to start out with a square like this, and then we're going to have an S right here. This stands for all of the sets that are inside of here. So for De Morgan's laws, we have an A, we have a B, and then we're also going to have a C. So what are these? Well, we'll call this A, we'll call this B, and we'll call this C. So inside of here, the first thing we have is A union with B. That means everything inside of that's in common with our A and B is not going to be in here because of this C, right? If we just looked at this, it would be all of this, all of this, and all of this. But what this C means is, and this is very specific, this can be found in the notes that are in the description below the like button. The C is the complement of a set. It's the set of all elements not in whatever we have that it's exponenting. And what it's an exponent of is this A union with B. So if we look at this A union with B, it's going to be all of this, remember all of this, and then all of this. So if this is raised to this C, the actual answer for this is going to be everything that's not included in it. So that means that we're going to have everything inside of here, 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 and here. So that's how that one's going to look. Do this one a little bit better. So we have our A, we have our B, and then we have our C as well. So what is this one? Well, if we look at just this inside here, A intersecting with B, it's going to be all of this and all of this in right here. So the complement of it is going to be everything else. So that means it would be everything outside of it. So just like last time, if all of this is the complement, is a complement, this is a complement, this is a complement, this is a complement, and this is a complement. So everything inside of here, we're going to want to erase because it's not going to be included with our result. So we'll take all this out, take this out, and so because of the complement, this is how we use the Venn diagrams to prove De Morgan's laws.